Good afternoon, Tech Nation, and welcome to Webinar Wednesday. We're excited about the presentation that we have featuring Adrian Jennings, Chief Product Officer of Cognosos. Webinar Wednesday would like to thank our sponsor, Cognosos. They deliver real-time location services to healthcare facilities, enabling them to rapidly deploy room-level accurate location services with proven ROI. Cognosos leverages artificial intelligence and long-range networking technology to eliminate complex, costly, and hardware-heavy RTLS installations, instead providing an ultra-lightweight, heavily accurate solution that delivers value on day one. For information on this company and today's sponsor, please visit cognosos.com. Also in your chat feature, you're going to see a welcoming message that will have the content that I just read, along with today's sponsor's website. Again, we'll encourage you to go visit them after the webinar is over, learn more about the services and products that they can bring to our industry. All right, let's have some fun today. Webinar Wednesday is in its 8th year, and it has become one of the most popular ways that biomeds and HChem professionals can easily earn CE credits for free. Here at Tech Nation, we think Webinar Wednesday has made the middle of the week a little more fun, and I have one WTF, also known as Wednesday Turn Fun, t-shirt for the first attendee that can tell me where today's sponsor's HQ is located. You can use the question feature on your dashboard panel to answer. First attendee with the correct answer will receive the WTF Webinar Wednesday t-shirt. While you're busy Googling the answer, I'm going to remind everyone that today's webinar is eligible for 1 CE credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer or your mobile device. If you have any questions, you can reach us at webinar@mdpublishing.com. As I mentioned earlier, our presenter today is Adrian Jennings, Chief Product Officer of Cognosos. Today, he will discuss the importance of RTLS confidence as it relates to the workflow automation in healthcare. Adrian, you may begin whenever you're ready.
Great. Thanks for the intro, and hi, everybody. One quick point, please don't take my accent to give you any guidance at all in terms of the location of our headquarters. That would be a mistake. So yes, my name is Adrian Jennings, and I've been in this real-time location business now for over 20 years, and those 20 plus years brought me to Cognosos because of what I'm going to talk to you about in this presentation, and how I think that we're delivering on that. So some of you may know my name from a previous webinar we did with Tech Nation, which went into a lot of detail about different RTLS technologies. And I'm going to reprise a little bit of that today, just quickly as an introduction, because there are some concepts that you need to know from that webinar. If you haven't seen it, I'd encourage you to go back and take a look after this. It's going to go and explain in a lot more depth what I'm about to do here in about 5 minutes. So that's where we'll start with a review of the importance of confidence in terms of asset tracking. And confidence is not a parameter normally talked about in terms of RTLS performance, but nevertheless it's critical, and I'll explain what I mean by that. We'll go on then to talk about how to properly leverage location data to inform and automate processes, which is really where the value lies. And I'm going to talk a little bit about that value chain and how to make sure that you're getting the most out of your investment. In terms of investment, we'll go on and talk a little bit about understanding how business cases is more than just return on investment. That's a key piece of it, obviously, but there's more to it than that. And we're going to dive into the notion of time to value. And that's going to culminate just in summary with some advice and guidance on choosing a solution that really drives a strong finance-driven business case in terms of improving your asset management. So as always, I like to begin with a puppy, and for two reasons. One is it illustrates a point, and the secondly, look at that guy, he's so cute. The point is about RTLS, and the question I ask people is this: if you had a puppy and that puppy kept stealing your slippers, would you hire someone to find your slippers for you, or would you train the puppy not to steal your slippers? And it sounds dumb because, of course, the answer is you train the puppy. Nobody hires people to find slippers for them, not in their personal lives anyway, but in business it happens all the time. Any business with a large fleet of critical assets spread over a wide area has trouble managing them. They tend to lose those assets, and the knee-jerk reaction is to buy a solution to find those assets. Pull out your phone, bring up the map, search for what you want, go to the dot. But the whole point of my presentation today, and what I kind of started off on the webinar before, is that the value of asset tracking technology is not in tracking assets, silly as that sounds. The value is in making sure that assets are always in the right place. You shouldn't be searching for lost assets. You should never be losing them. And that's what we're going to talk through here. Now, the concept I want to reprise from the last webinar, and I said to go back there and delve into the details if you want, is it's understanding tracking accuracy from the point of view of two dimensions and not one. And what people will generally talk about is accuracy. And many RFPs are written in those terms. We need a tracking system that can deliver X meters of tracking accuracy. But it's only half the story. I drew a dartboard here. I'm horrible at darts. But if you asked me, Adrian, could you hit a bullseye? My answer would be, well, sure. If you gave me enough throws, I'd probably get one eventually. And here's a representation of how I might throw darts at a dartboard. So I'm answering yes, and it's kind of truthful, but it's not telling the whole story. Is my accuracy bullseye level? Well, not really. If we count how many times I hit the bullseye out of 100 darts there, I got 2. There's 2 dots in the middle there. Inside the bull, which is the ring just outside the bullseye, I got 12. That's all the dots in the bull inside that ring. Inside the inner ring, 69. Inside the outer ring, 92. On the dartboard, 97. 3 of them missed completely, right? So this is a cumulative thing. This 97 includes all of these 92, which includes these 69, which includes these 12, which includes these 2. So that's just the statistics of how I did, and we can draw that on a graph. And the graph would look like a cumulative error probability curve. So that's probably not something you're particularly familiar with, but it's very simple and obvious once you see it. If we have a count of my the number of times that I threw a dart within a certain error distance of the bullseye, let me lay the dartboard here. So we've got the bullseye and the bull and the inner ring and the outer ring and the board. And let's plot the numbers. So so down here at the bull, I got 2. So we can plot our 2. Inside the inner ring here, I got 12. So let's go ahead and plot the 12. Let's plot all the other numbers, 69, 92, 97, and draw a line. And that is a full description of my ability to play darts. It tells you for any error circle, what are the chances that I'm going to get a dart inside that circle, right? So for this inner ring, I read up, I get to 69, I read across here, 69% of the time, I'm going to get inside that circle. That's what it means. That's what a cumulative error probability curve is. Now, if I plotted the curve of a pro would look like this blue line. You know, if you asked a pro, how many times can you get a bullseye out of 100 darts? Probably most of the time. 92% maybe. How many times within the bull? You know, 97% maybe. You know, so blue is good, red not so much. And goodness is up in that top left-hand corner. For any given error, even for very small errors, you get a very high confidence that you can throw at least as good as that error, if not better. Right, so that's how you read these charts. And what does that look like? It looks like this. This is how pro throws darts. They throw them in a very tight spread. Anybody who's good at anything can aim and hit almost all the time. a darts player, a golfer trying to get on the green, an archer trying to hit a target. It's all about the spread. So that's what confidence means in terms of location. And with a location system, you talk about errors from where a thing actually is. It's located here. Where's the RTLS telling me it is? Is it telling me within 2 feet of where it is, 4, 6, 8, and so forth? And with what level of confidence? So better performing is up into the top left corner. Worse performing is down and right. And that's kind of the characteristics you need to judge a solution. Going up and left tends to mean needing more infrastructure. More accurate solutions tend to have more fixed reference points than the lower accuracy systems. Going up and left often means in room or nearly in room, kind of in the doorway infrastructure, which is a lot. Every room, that's a lot to put in. It nearly always means higher cost, and it nearly always is not how systems are asked for. If you ask a vendor, can you achieve 3-foot tracking accuracy? This red vendor and this blue vendor, they're both going to say yes. Right? The red vendor is going to say, well, 3 feet, yeah, I can do it. And they're not going to mention only 35% of the time. They're not going to mention that 65% of the time they're going to be worse than that. The blue vendor is going to say yes with great confidence. 3 feet, sure, look at that, 99%, fantastic. Now, the thing is that people generally only talk about this error axis. Overwhelmingly in specs, people talk about their accuracy in terms of a distance. Overwhelmingly in RFPs, you see accuracy asked for in terms of an error distance, and almost never is there a conversation about confidence. And you can see from this graph why that's critical. If you ask the blue vendor and the red vendor to respond to an RFP asking for 3 feet of accuracy, they both say yes, and clearly they're not both the same. Why should you care? Well, let's move away from dartboards and put that spread of results over a hospital. Here's an asset somewhere. You ask the RTLS, a stationary asset, but there's error in a location system, and you ask it 100 times where it is, and it returns these 100 results. And if you were, very familiar with Google Maps, I'm sure, and what Google shows you is this. It doesn't show you all the dots. It shows you an error circle and the center of the error circle. And it's telling you that, you're somewhere in that circle, and here's the middle. And that error circle, as you know, changes size depend on how accurate that it's tracking. If it can't get a GPS signal, for example, it gets pretty big. So if you're asking the question, where's the syringe pump? The answer is, well, somewhere in that circle. Let's check this room first. If it's not there, we can check this one. There's a couple of other rooms, a hallway, maybe a stairwell, but that's not many doors to open and look in. Should be able to find that. Job done. That'll work for finding things. But alas, as I said, don't be a slipper finder. I hope I'm not the only Monty Python fan on here, by the way. But yes, I accuse you of slipper findery because that's not where the value is. That thing's already lost. Let's not lose it. Let's ask a different kind of question, not about the asset. Let's ask a question relative to the process of managing assets. Let's ask a question, is this syringe pump available? And if we have a situation here with 4 patient rooms, we have a clean room, and we have a soiled room. And let us say that, what does available mean? Well, available means in the clean room. Unavailable means in any patient room or the soiled room. And if we ask that same tracking system, is the syringe pump available? The answer is we have no clue. Because we literally don't know which of those rooms it's in. We can find it well enough if we were searching for it, but we can't make any inferences about its state or whether we can use it. So that's what I want to get to here. That's a very quick run through what we did in the last webinar, and I go into a lot more detail about the different technology choices. But here we're going to take a different route out of there, which is moving beyond where's my stuff and into how's my process. Right, this is the move from slipper findery up to actually training the puppy, not finding lost things, but ensuring things are never lost. How? By improving and automating the process. So let us start by understanding a little bit about what I'm calling the RTLS value chain from bottom to top. And the minimum value that a location system will provide is a physical location. Let's say latitude and longitude. You can feed that into a map, put a dot, and you can use that to find things. That is the base level of value. The next level up is logical location. Logical location, by that I mean taking the location of that dot and defining pretty much in hospitals, what room is that in? What kind of room is that in? What is the function of that room? So that's a logical. This room might one day be a clean room. We may do a refurb, and next week it's a patient room. The physical location is the same. The logical definition changes. So what kind of room is it in? So let's say floor 2, clean room B. And then when you know that, you can start to make inferences like availability, like what's the stock level of items in that clean room. So you're starting to get something much more already than just where's my stuff. Now we're answering the question, how's my clean room? From that, we can start to make tactical decisions. We can monitor the stock in a clean room, and when it falls below a certain level, we can replenish it. And we can create some automation around clean room replenishment. And I'll come into that in quite a bit more detail as we go through the slides here. So that's a tactical decision. But over time, when we monitor these inferences and logical locations over time, we can start to understand trends like equipment utilization. And equipment utilization is going to help us make strategic decisions like, what is the optimum fleet size? And I think it's very commonly known, of course, that hospitals have really quite low utilization for historically jolly good reasons, which is you'd better have enough assets on hand that you can always find one, even if they're scattered to the four winds, because the process isn't quite working right. And that's what we're going to come back to here in terms of the highest level of value. So bottom to top, minimum value, physical location, inferences and tactical decisions and trends and strategic decisions climbs up a value chain where the higher we go, the more value we're getting out of this solution, the more return we're getting on our investment. And the thing about going up that stack is you've got an increasing cost of making bad decisions as you go bottom to top, and you've got an increasing time to correct bad decisions. You know, it's bad for a clean room to run down to 0. It's really bad simply not have enough assets in the hospital, period. You can fairly quickly correct a clean room by replenishing it. It's much longer task to correct your inventory level and go through a procurement cycle to bring more equipment in. So the higher you go, the more value, and the higher they go, also, the more impact you're having. So let's bring in the notion of RTLS confidence, what we were just talking about, which is why I think this is super critical to understand, is if you're basing decisions on the location of things, the confidence you have in your decision making is the confidence that's being delivered by the tracking system. So given a physical location, what is the confidence we have in translating that into a logical location? Let me translate that for you into normal person speak. Given the scatter of dots, what's the probability you can tell me which room something is in? And let's say you get 75% room level determination. That gives you 75% confidence in your inferences, 75% confidence in your tactical decisions, in your trends, and your strategic decisions. And let's think about that a different way and turn that on its head. What's the error rate? It's the opposite side of that. 75% confidence in your tracking system means 25% of your inferences are wrong. 25% of the time you're making the wrong tactical decision, et cetera, 25% wrong strategic decisions. Making a mistake 1 in 4 times is really not good at all. And so you see how this confidence, this seldom talked about confidence value, is absolutely the critical factor in determining where is this going to deliver value. But it's not just as simple as that. Other data comes into each of these decision-making steps. You don't just decide to replenish a clean room based on the count of the equipment that's in there. Other factors are important, like availability of clean equipment, like the availability of staff to do the replenishment, and so forth. So each of these steps has other input data, and each of these steps has their own kind of fidelity. Let's say, really generously, by the way, let's say we have 98% confidence in this chunk of other data here. So if I feed 75% confident location information to this layer and 98% confident other data, the confidence in my inference is 98% of 75%, which is 74, give or take. At this level, it's 98% of 74% is 72, and so it goes up. So it gets worse and worse. By the time you get to the top here, 30% of the time, we're making bad decisions. So the point about bringing this up is just to show you that, it's bad enough to have low confidence data coming in the bottom, but errors accumulate and lack of confidence accumulates to the point where you end up in a situation where it becomes useless. If the fidelity of this information coming in here is now up, in the 90s or so, okay, it still accumulates, but you're still up there at the kind of 9 times out of 10, you're getting it right level at the top. Pretty good deal for that level of strategic decision making. So when we go back to the value chain here, we can add to the increasing cost and increasing time to fix another issue, which is decreasing confidence of the data. And so when you think about how far up this value chain can I go with the data that I've got, you end up with this kind of value threshold, which is as these confidence levels kind of drop and drop and drop, where do I reach a threshold if it's just no good anymore? Maybe your threshold is 95% and you reach that here, in which case you really can't use the location system for anything much more than finding things. If the confidence is good enough that it gets you up to here, then you can use it for tactical decision making. If your confidence is great and it gets you all the way up to here, you can lean on that data for strategic decision making, right? So it's super critical. This is the old rubbish in, rubbish out, right? All your data right from the base level needs to be as good as it can possibly be, and then you can get the most value you possibly can out of it. So super critical. That's how confidence of the location system translates into confidence in decision making, and translates directly into how much value can I get from the location system? How many of these steps can I go up before the data isn't useful anymore? So let's go back to this and talk a little bit about where we were here with error versus confidence, right? And remember that the blue system is the really good one and the red system is the really low one. And what we said was the blue system is probably quite a bit more expensive than the red system, and that traditionally for a long time has been the truth. So let's look at a slightly different set of axes and kind of transition into talking about the business case. And if we look at system value against system costs, right? So how much money you have to put in is the cost, and how much money you get out is the value. And we can draw a line where those two things are equal, that the amount of money, every dollar you put in, you get $1 back out. You end up with 0. Anything below that is a negative return on investment. That region there is the region of every dollar I put in, I get less than $1 back. That's bad. You'd never purchase that solution. What would be the point? Everything above the line is positive ROI, and the further you go above the line, the more positive. So there's a definite yellow zone here, which is, yeah, I'm getting, $1.10 back for every dollar I put in. I'm making 10 cents per $1, that's okay. I mean, that's a positive ROI, and you magnify that up to very large scale. That's actually very important. But where you really want to be is up here. I want to be getting $2 or $3 out for every dollar I put in, and that is a really solid business case then. And obviously, step one of a business a purchase decision for a solution like this is going to be in return on investment. So you want to be up in the green realm. If we just change the axes a little bit and look at system cost versus confidence, what we said was that generally speaking, historically, higher confidence systems have cost more. And we can draw kind of a historic trajectory of how that has panned out over time, like this, which is it's kind of one of those laws of diminishing returns. So certainly, more expensive solutions, which are things like more rare, higher tech technology, which has inherent cost, or much higher density infrastructure, which has just a high cost of the infrastructure. As you've moved up, there's sure enough the confidence increases as the systems cost more, but it's not linear. There comes a point where you're starting to kind of peel over there. You're getting to the point of diminishing returns, and sure enough, probably it does flatten out somewhere out there. That there's just only so far you can go to make things better. So if we go ahead and plot, and I went into this in much more detail in the first webinar in terms of a little bit of the history of the different kind of solutions, but I'm going to plot the buckets of solutions on here, and they're not really dots. They kind of vary across a region. So lots of vendors are out there making kind of zone level accuracy based on pretty low cost beacons. Bluetooth's an example there. It's in the realm of slipper findery for sure, but they don't cost very much. So they sit down there. Where the most traction has been in healthcare has been in the infrared and the ultrasonic type systems, which do give you a level of room level accuracy at the cost of quite a lot of infrastructure. And then up at the diminishing returns end of the thing are the super precision systems, things like ultra wideband, which really don't feature too terribly much in healthcare, just on the basis that it's cost prohibitive to make those things work, and the precision supply doesn't really drive a broad swath of use cases. So the other thing we talked about in the last webinar was this kind of new breed, we call it RTLS 2.0, of technologies which take low cost infrastructure and leverage artificial intelligence to do location in a completely different way, actually, to use machine learning to take a classification approach to room level accuracy. And that gets you off this traditional curve. It's different, it's fundamentally different right from the ground up in terms of how the location is done, and it does allow you to create high confidence with low cost infrastructure. And that's just overlaying our ROI color scheme on top of that. That's obviously where you need to be. For a long time, RTLS has flirted with the one-to-one line. That if you put cheap enough systems, okay, they don't have a huge amount of value, but it's still a positive ROI. If you move up here, yes, if you do it right, you can get an ROI out of the IR and ultrasonic systems. Really no ROI out here. But these RTLS systems have not taken off like wildfire in healthcare, and the reason is because they're all flirting with this yellow ROI region, which is where we're excited to be in this realm up here, where we think we're making a fundamental change. So let's go back to the value chain, and let's kind of take all that and get it really grounded in a very specific example. So we talked about physical location up to logical inferences, tactical decisions, trends, and strategic decisions. And let's take that example and apply it, as we've been talking here, specifically to the clean room replenishment problem, and go through really how things are currently tend to be working, and how you can improve, number one, and automate, number two, that process using the right RTLS data. So here's a simple view of just a number of items on hand. Pick an item, let's say syringe pumps, and time, over time. And here we have some thresholds for our clean room. We have a maximum level, our replenishment level. That's where we want them to be. We don't really want to get below a minimum level. We certainly have some contingency in there because you just really don't want to run out. And if you do, by the way, that's the process broken. When the process works, nobody should have to search for anything. You should know that you can just go to a staging area like a clean room or a place in the hallway or another kind of storage room where equipment is held. You should know that you can go there. What you need will definitely be there, and that's all you have to do. It's only when you open the door and what you need isn't there that you have to pull out the map and go on a treasure hunt. Okay, so let's draw, with no regard for replenishing this, let's draw a curve of kind of deep depletion. And first thing is, well, this is not good at all. You certainly never want to get down to zero. And there are two ways not to get to zero, of course. One is to replenish more often. The other one is to buy more stuff. And that's often what happens. I mean, as I said, anecdotally, and hospitals have very low utilization of their assets. And the reason, and it's a jolly good one, is this, that if the equipment is not available, that is a major issue in terms of providing the level of care required, and the best and quickest way to fix that is to buy more equipment. Well, it's the quickest, it's not the best. Anyway, so we have a max level. Now, let's talk about replenishment. We need a replenishment plan. We don't know this curve, by the way. Nobody knows that right now. You'd have to physically go to a clean room and count how much equipment is in there. We don't do that today. What we do is we do periodic replenishment. We say, look, okay, what's the maximum rate of consumption? And let's try never to get out of the max min band. And so that's our period of replenishment, and let's just do that forever. If we replenish that frequently, we should be good. But let's keep some contingency stock on hand just in case we're wrong. So when you do that replenishment and you always bring up to the max level each time you do that, then it looks like this. And immediately you can see, well, that seems like a very bad idea, doesn't it? Because we certainly didn't need to do this. We probably didn't need to do this. We probably didn't need to do this one over here. So that's not good. What we've done is we've ended up with a good deal of stock just sitting around above the minimum level. So the first thing we can do is say, well, let's just reduce our max level a bit. We've got some buffer space there. We can bring that down. We've made a savings. This is great. We've reduced the number of assets we have to hold. But actually, wouldn't it be better if we did know? Let's say we did have a tracking system. Let's say we did know with very high confidence what's inside the clean room. Let's say that we could count those. And let's say we knew that black curve exactly. Well, then we could set a replenishment threshold. And we could say that if our stock ever falls below that, we're going to send an alert down to Biomed, and they're going to go replenish that clean room. And that would look like this. Now, you don't want your replenishment level to be your minimum level because you don't instantly get up there to the clean room. There's a time lag. So you set a level above your minimum acceptable threshold that gives you enough time to get it done before this line would have got down to zero. But what we've done here is we've massively reduced the number of times you have to service that room because we're doing it proactively. We're actually optimizing the process now. We're saying, look, we have full visibility. It's almost like we have a camera pointing in that room and we can see all the time. The clean room is almost self-aware, right? It knows what's in it. It pings us to tell us, hey, bring more syringe pumps, I'm getting low. And that gives you the confidence to let the stock run down lower. Now, we still have this giant contingency stock here. Well, you know what that is? That's storage. this is about 50% here of this total population, right? What that's telling you is this gets up to our trends now. We've gone through tactical decision making. Here's a trend. Here's a 50% utilization rate. If we're keeping the stock always between these thresholds, none of this stuff down here is ever going to get used, as long as we definitely can guarantee we could do that. When we're blind, we can't. We have to have contingency. When we've got visibility, we know we can reach time. We don't need that storage. Let's do this. But yes, we're going to have a reserve buffer. Of course we are. Nobody's going to plan to get to zero. But you certainly can reduce the holdings. And that is exactly where the strategic decision making is now, in terms of equipment level reduction, in terms of the replenishment frequency reduction. These are big savings. This is you know, multi-million-dollar savings here by reducing the fleet size, because you're better managing the process of distributing the equipment, because you have visibility real time into stock levels and availability, and that allows you to keep these reserve buffers as low as possible. So if we bring our value chain back in, we can kind of connect up here different pieces of this. So our logical location is the thing that's telling us the count, right? If I know how, if I know that a syringe pump is in the clean room, I'll count +1 syringe pumps in the clean room. But that had better be good information. That had better be high confidence, because the inference I'm going to make on top of that is when I need to replenish it. And that's the tactical decision I'm going to make. And we need to get that right. That needs to be a high confidence decision. We can't be messing that up 25% of the time, 30%, 40% of the time. Right, so high confidence count gives you a high confidence view on when to replenish. And then there are multiple trends in here. These are a few. Replenishment time, you can measure. We can measure that. We know when we cross the threshold. We know when we counted the full inventory in there. We can monitor the replenishment time over time, and that allows us to set the replenishment level. Maybe that has to go up and down. Maybe there are some times of the day or week where the replenishment time is longer or shorter, depending on staff levels, and we have to adjust the replenishment level to cope. Maybe we have to put it up a bit so we get early warning to give ourselves a bit longer to do the replenishment. Can do. That's a trend we're measuring. Usage rate. That tells us how quickly this might get to zero after the replenish level. That again is informing us how long in advance we need to make these decisions. What is the max level you need? Who sets the part level? How do we know we need 8 syringe pumps in this clean room? We can monitor over time. We know how they're used, and we can set that based on data. And then, of course, the strategic decision making is the fleet size. This is where the big savings are. This is where you start to be able to get your utilization of equipment up from 40 or 50% to more like 80%. And that's a 30% reduction in fleet size. That's huge. So that is how location translates into very specific process improvement and automation. That is how confidence leaks into there. And remember, the big saving is here. That's where the big dollar saving is, but you got to get all the way to top of the value chain before you get that savings, which means your data coming in the bottom here, this count number better be really high confidence. That's why I press on this confidence number so hard all the time. It's absolutely critical. Let's turn lastly to just the finances of this. We've talked about cost and value a lot here, and we talked a little bit about return on investment, but I want to move that conversation along as well beyond return on investment and talk additionally about time to value. If confidence is the key that you have to add to accuracy to understand RTLS, then time to value is the key you need to add to return on investment to understand the business case. So here was our ROI chart that we drew, and we drew a kind of a one-to-one break-even line up here. Below that, you're losing money. Above that, you're making money. And we talked about, you know, where would the 2-to-1 return be? Where would you get $2 out for every dollar you put in? That's great. And you do your ROI calculation, and you calculate it out over however many years, 1, 2, 3 years, and you do the sums, and you say, yes, in this time period, I'm going to get more back than I put in. But when do I start to get money back? This is a question the CFO is going to want an answer to. The CFO is going to make an investment in this technology, in this solution, and they're going to want to know, when do I start seeing the dividends? Well, let's talk through that, and let's start with what's in this thing called system cost. Well, I kind of talk about above the waterline and below the waterline costs. You think about icebergs. Above the waterline, here's the vendor quote. What's in a vendor quote? Pretty much always a combination of tags to put on your mobile assets, software to interact with the location. Infrastructure is the hardware, that's the fixed hardware that actually tracks the tags. And services, some level of engineering services to install and deploy the solution. And we're talking about timing, so when do you get charged these things? Well, tags normally you write a contract and the contract gets signed and a bunch of hardware gets shipped, and in the box comes an invoice. So, you know, on receipt of right at the start of the contract, tags and infrastructure. Software, normally that would get paid annually. Lots of people have an annual fee for software, and you would kind of start that on a go live date. And services kind of as delivered during that installation period. So let's scooch that up here to make some room and talk about below the waterline costs. These are the additional costs outside and above and beyond the vendor quote that are going to land on you as a customer. All the stuff you have to do, networking equipment. If these infrastructure devices need networking, it might be wireless, it might be access points, it might be wired, which is PoE and switches, but there's often a networking component required, that's a cost. Lots of traditional solutions are on-premise, deployed on-premise, so you've got to host the software. You've got to buy servers and disk drives and provision those things. You will have to support the vendor installing the solution. There's planning, there's escorting, there's monitoring and verification. There's a lot of manpower that will be required of you during the installation phase, and that could incur lost revenue as well. Anytime you are impacting actual treatment areas, if you have to keep a patient room empty for half a day, for example, to put something up in the ceiling or at the door, that's a lost revenue opportunity, and that's cost too. When do those things land? Well, all this hardware has to be provisioned at the start of the installation. That's kind of needs to be there from the get-go, and support and lost revenue kind of go throughout the installation. And installation can be quite a period of time with some of these complex infrastructure solutions, maybe 6 months or so. So here's a cash flow chart, a waterfall. If you're not used to these, it's pretty simple. You start with no money, and everything that you pay is orange and negative, and everything you get back is blue and positive. And so for the first 6 months, it's all paying out. Tags and infrastructure and servers and networking. Over the intervening months, the services and the support and the lost revenue impact. Finally, at the end, a chunk of software probably that goes live there. And then you start chipping away at getting some value back. And I've just made a guess. This is a pretty good ROI, by the way. I've said, look, let's say every month you get 10% of your investment back. And so 10 months would get you 100% back. So it took us 6 months to install, took us 10 months to get our investment back. Where do we cross the zero line again? 16 months out. 16 months is when you tell your CFO is your time to value. That is the first moment, well, 17 actually. 17 months is the first moment you start to get money back. The rest of the time you've been paying off the investment. So that's a long time. You know, you're talking about almost a year and a half after you start, which is a long time after you've made a selection and signed contract. So it's a long time to value in a traditional on-premise infrastructure heavy solution. So we talked about, and go back to the other webinar, leveraging things like AI and machine learning, a new breed of RTLS that changes the game in important ways. There are always tags, there's always software, those don't go away, but you should definitely be seeking low infrastructure options. You can't sacrifice confidence. can't, because it just doesn't do anything much more than slipper finding anymore. But if you can reduce infrastructure and maintain the same level of confidence, then that's obviously going to be better. That's what these new breed of solutions do. Services are more or less proportional to infrastructure. The giant burden of installing is the infrastructure. So if that goes down, services go down accordingly. Seek solutions that have a very lightweight network requirement, if any. That minimizes that burden. Seek cloud-based solutions. Why the heck are you buying servers and disk drives and managing them and worrying about backups? The cloud is here. It's the AWS and Amazon and Oracle are better at managing server farms than just about any of us. Cloud-based solutions really eliminate that cost item completely. Certainly seek non-disruptive solutions. Low infrastructure solutions get installed quicker, so installation support is over a shorter period of time, but also they differ in terms of how complex the installation of the infrastructure is and where the infrastructure has to be placed. So you're looking for non-disruptive solutions there, and in particular ones that don't get in your way of your normal operations. And if you go to that world, then this kind of does this. Some of the things disappear, some of the things get smaller, and certainly the installation time gets shorter. So we can draw that picture as well. And this is kind of apples to apples, the same payback, but now we've got only a 60% of the cost level, which is not unusual. Just having removed or reduced a bunch of line items, it costs less, it's deployed quicker, you're into getting value back faster, and in this case, it's 9 months to get to that crossover point. We're going from 16 months down to 9 months in terms of time to value. Much better. In the same year is great. CFOs like that. But let's go faster still, because many of us in our professional and personal lives pay for solutions as a service, meaning we pay an ongoing service fee, and we don't have giant outlays for hardware and all these kinds of things. They're almost always, I should say, completely always cloud-based, so these have no IT overhead at all. High availability, that's built into cloud-based solutions. Continuous product updates. We've all woken up in the morning and had a new feature on our iPhone because it was pushed overnight. You're always on the cutting edge of the latest version, not just in terms of features, but in terms of bug fixes and security patches, and you don't have to do anything. Nobody sends you a bucket full of floppy disks to upgrade. Usage-based pricing is a common way for these things to be priced. And as I said, in terms of time to value, no large initial outlay. And what does that look like on a waterfall? Your initial outlay is really quite small, and you're about 20% here. You're really the outlay. You're not buying all the hardware, right? You are actually paying for the services and supporting the installation, which is very quick. And you're very rapidly into payback. It's not 10% anymore. You're getting 10% back, but you're having to pay a monthly fee. That's as a service. That's how it's charged. But nevertheless, we're getting back into zero territory in 6 months. So that's fantastic. And that is a huge change from 16 months, almost a year sooner that you get back in the black. And that's what makes a really strong business case for the CFO, not just ROI. It's also about time to value. So, you know, if I had to summarize, there's 3 categories of things that you really need to be thinking out. And they're kind of obvious, but let's break them down. Maximize value, okay? Maximize value means seeking solutions with high confidence room level accuracy. On top of that, you can build all the way up to strategic decision making with confidence and leverage the biggest value that you possibly can. Seek solutions which leverage location intelligence to improve and automate critical processes. It's not about finding things, it's not about dots on maps, it's about how do we reduce the asset fleet size by better managing our clean rooms, as an example. Don't be a slipper finder. Minimize cost, obviously. What does that mean? Seek low infrastructure solutions. Seek solutions with very light network infrastructure. Seek cloud-based solutions. Seek solutions that are non-disruptive to your workflow, and in particular, solutions which don't impair operations completely during installation. And then finally, minimize time to value. It's about ROI, value minus cost, that's return on investment. Time to value is a separate thing, and seek SaaS-based pricing. Now's the time. The whole world's moving there. There's a good reason it's doing it. And so that's the summary, and that's the end. I hope that all makes sense. There's a lot to pack in to our time together here. I do hope you go back and look at the other webinar, because it'll fill in some of the blanks that you may have been left with, but certainly have a few minutes here to answer any questions.
Absolutely, Adrian. Let's go ahead and jump into a couple of the questions that have come in. The first one is, an attendee didn't quite understand what you meant when you described ProPAR. Can you explain that again?
Oh, yes, sorry, I probably accidentally used one of our terms for something, which is, so PAR level, what is the level of equipment you need in a clean room to make sure that you're serving the clinical staff, which is normally replenished periodically, PAR, periodic asset replenishment, and that's not a great way to do it. It's not the best way to do it. It's the best we can do today. With the visibility, you can be proactive. That's what I meant by ProPAR, proactive replenishment. By proactive, I mean watching the stock levels, getting automatic notices about when to replenish, and doing that kind of on an on-demand basis rather than a periodic basis. Much more efficient way to do things. So that's what I meant by ProPAR. ProPAR is just our way of, that's just our term for it.
Perfect. And we've got time for one more question. Are there metrics that can predict how much a typical hospital can save by reducing the number of assets?
Yes, there are. So there's a couple of ways to answer that. One is that there are certainly industry data that can show that on a general level. So there's certainly industry data and reports that show what a typical utilization rate is across hospitals, and there's plenty of places that have used these systems that can talk about what kind of utilization improvements you can make, and those two numbers can give you an idea of what the ballpark figure is for a saving based on any given hospital size, right? So that's one way to answer it. The other way to answer it is, like others, we have specific tools to get a bit more granular than that for any particular facility. And it's quite quick to go through and plug some numbers in and get a much more specific number tailored to your particular hospital. So that's something we can help with too. So yeah, so there's definitely numbers. There's enough track record in the industry of these things being deployed to have good confidence in what the outcomes will look like.
Great. And quick note to the attendees, I know Adrian referenced a previous webinar that he has done with Webinar Wednesday. So if you look in your chat feature right now, there is a link that will take you to that webinar and our archives, but you could also get there by visiting webinarwednesday.live. Select the on-demand option that would take you into our archives. You'll see a search bar there where you can search webinars, type in the company, the sponsor's name today, Cognosos, and it'll pull up their webinars. Of course, today's presentation will be added to that archives within 24 hours. Adrian, I want to give you one more big thank you for the presentation today. And of course, we want to encourage everyone to visit the sponsor. You can find out more about this company by going to cognosos.com. A quick reminder, you can obtain your CE certificate by completing the post-webinar survey. The survey is emailed 1 hour from now. You do need to complete it to receive the certificate, and you'll be able to download the certificate from your computer. If you have any questions, you can reach out to us at webinar@mdpublishing.com. We will be back next week with another great webinar. Go ahead and register for it at webinarwednesday.live. You can see our upcoming calendar for all of the webinars that we have scheduled. All right, guys, make it a great day. We'll see you next week. Enjoy your afternoon.